Welcome back everybody to evolution versus creation, and I think you guys will enjoy this video. I know it's a little bit on the longer side, but there's just quite a bit to cover, and we're going to go through the age of the earth and what is some of the other evidence that we see. Well, I shouldn't even say some of the other evidence, some of another narrative to the evidence that we do see and that we have seen. So again, a lot of these videos are simply showing you the other side of the coin that we do not get in secular science. We only get one side of the coin, and there's always two views of interpretation based on the evidence that we see. So again, we all have the same evidence. We have the same rocks, we have the same layers in strata, we have the same solar system, we have the same oceans, the same deserts, the same dirt, and so it's just a matter of how you're interpreting the evidence that we do have. And so I'm just going to keep going with another narrative that you haven't probably heard before. So the main narrative is what we get in textbooks and from evolutionists, which is that the earth is roughly 4.6 billion years old. And of course, evolution needs that amount of time in order for it to work. And so what I find kind of funny about evolution, macroevolution, is that even if you wave this magic wand of time, macroevolution is still impossible. It's never been observed, and neither in the fossil record or today. And so it's not even a good theory. It's actually just a really bad hypothesis. And so but anyway, a lot of what we believe today about the earth has come from secular scientists and things like radiometric dating, and I'm going to go through that in great detail in this video. And so yeah, I hope you enjoy it, and let's get into it. And so the first thing I want to look at is this ship that had a box of coins in it. And you might be wondering, what the heck does this have to do with the age of the earth? And well, the ship itself has nothing to do with the age of the earth. But there's a principle here that I wanted to share with you because we can apply it to some of the evidence that we find for the age of the earth. And that is that the ship was found on the seafloor that had a box of coins in it, and they contained various different dates stamped on them. A number of the coins had a date of 1542. However, numerous other coins had a date of 1658 stamped on them. And so even though a number of the coins were from the 1500s, which were older, the actual date of the ship sinking had to be after 1658 based on the coins that they found with this date. And so when it comes to the age of the earth, we see this similar principle, that if even one thing on the earth or solar system reveal a young age, then that presents a problem for the earth being very old, just as the coins from 1658 provided the most accurate timestamp for the ship sinking, because despite all the coins from the 1500s, the ship could not have sunk before 1658. And so I want you just to keep that principle in the back of your mind as we move forward. So in 1770, George Buffon concluded that the Earth was 70,000 years old. And then in 1862, it was calculated to be between 20 to 400 million years old. By 1902, 2 billion years old. By 1969, the Earth was believed to be 3.5 billion years old, and today it's believed to be 4.6 billion years old. And that's an age growth of over 18 million years per year, or 35 years per minute since 1770. And so, it's just a little bit crazy how old the Earth has become in just the last couple hundred years. And, you got to keep in mind, too, that radiometric dating wasn't invented until 1905. And so, so many of these numbers are literally just coming from their interpretation of what they're seeing in the earth. There's not necessarily science behind it. There's a lot of theory and a lot of assumption behind it, and a lot of people applying a certain worldview, the worldview of evolution, to the evidence that they're seeing, and then interpreting that evidence from that worldview. And so the actual like, for example, the actual layers that we see in the earth, like I've already gone over, they believe to take millions of years to pile up one on top of the other. But we've seen through catastrophic events that can happen incredibly quickly. And so, again, the age of the earth has been rapidly increasing, as you can see, over the last few hundred years. However, God says this, that in the beginning, God created the male and female. The Bible says mankind was there from the beginning, not millions of years after the very beginning. And it also says that the earth is under 10,000 years old, and most scholars believe the Bible to say it's under 7,000 years old. And so another thing to keep in mind is the worldwide flood that destroyed everything 4,400 years ago. And just the impact that that would have had on the earth is remarkable. And it would leave behind evidence that we absolutely see all over the planet today. So just as a quick overview here, this is the creationist timeline versus evolutionist timeline. So in the creation timeline, just over 6,000 years ago or 6,000 years, in the beginning, God created this. Evolutionist timeline is in the beginning, dirt created this. And, it says down there 20 billion years ago, the Big Bang happened. That's not believed anymore. It's now 13.7 billion years old. And then life, or the Earth formed 4.6 billion years ago. Then the first life appeared 3 billion years ago. And then man evolved 3 million years ago. And now that man evolving 3 million years ago is also out of date. It's now 300,000 years. It's very difficult to keep up with evolutionists because they flip-flop with these numbers. And so it's just hard to keep track of what they believe today because it's probably going to change tomorrow. So today we're at man evolving 300,000 years ago. And so that's just a quick timeline to see the breakdown between these two different perspectives. So let's get into it, guys. Let's look at a number of surprising and revealing facts about our planet when it comes to it being old or it being young. The first is human population. As of 2021, the world population is approximately 7.8 billion people. In 1999, the world's population crossed over the 6 billion mark. In 1985, which is the year that I was born, there were 5 billion people. In 1810, we had about 1 billion people on the planet, and this is found in Moral Earth Science on page 503. 1 billion people in 1810. In Jesus' day, it is estimated that there were about 250 million people on the planet. 250 million. And evolution teaches that humans have been here for approximately 300,000 years. However, taking the rate of population growth that we have observed and taking into account, natural deaths, wars, plagues, and catastrophes of all kinds, that would literally mean that based on this rate of population growth, that right now we should have 150,000 people per square inch if we evolved 300,000 years ago. And you might say, well, how did you come up with that? And the next two slides are for you math lovers out there. And I wrote these out because I wanted you to be able to follow along with me, and you can feel free to check the math for yourself. But through actual observable mathematics, we can see that evolution 300,000 years ago is impossible. For man to be here that long, based on population alone, is impossible. So again, this is all written out so you can follow along with me and pause it if you need to. But in 1922, Berlin released a census on world population with a reported number of 1.8 billion people. The human race must double itself 30.75 times to make this number. And how do we know that? Well, just through simple math. At the very beginning of the first period of doubling, there would be only 2 people on the planet, which starts us off with the lowest possible ratio. In the second period of doubling, we would have 4 people, the third 8, the fourth 16, the 10th 1,024, and so on until you get to the 31st doubling, which would have over 2 billion. So by simple math, we see that the population must be doubled more than 30 times, but less than 31 times to reach the numbers of the 1922 census. By logarithms, we find that the actual number is 30.75. So after allowances for natural deaths, wars, catastrophes, and losses of all kinds, if the human race were to double itself 30.75 times, we would have the stated population. Having a record of the Jewish population as an example that we can look to that's observational, we see that between Jacob and the 1922 Berlin census, there is roughly 3,850 years. So according to the Jewish numbers of 1922, there were over 15 million Jewish people. Therefore, the Jews must have doubled their numbers 23.8758 times, or once every 161.25 years, to go from Jacob to the 1922 population. So to be incredibly and unrealistically conservative, let's pretend it takes 500 years for the human population to double each period. 500 times 30.75 is only over 15,000 years to get to 1922 population, and that's using 500 years being the doubling period for every single time. So from two people to go to four people is 500 years, and from four people to eight people, another 500 years. And you do that all the way up, we would find that we would still only have 15,000 years to get to the 1922 population. Using the theory that man evolved 250 to 300,000 years ago, and this is again just a number that completely keeps changing. It used to be 3 million, but let's take the 255 or 100,000, just to be more on the conservative side, and divide it by 30.75 to see how long it would take on average to double the population. It would take 8,100 years for each period of doubling. If we evolved 250,000 years ago, it would take 8,130 years for every period of doubling, which is of course laughable and completely impossible. So from 1810 till now, the human population has not doubled, tripled, or quadrupled. It has gone up over 7 times what it was just over 200 years ago. And keep in mind that the population still exploded in the midst of plagues, mass genocide, and 2 world wars, with more loss of life than any other century in history. Now, of course, these numbers obviously increase faster with the more people you have, and this affects the rate. However, this still leaves us with a big problem. Let's just pretend monkey to man happened just 100,000 years ago, and the population doubled every 1,612.51 years, which is 10 times longer than what we've observed the Jewish population doing. The present population of the globe would be approximately 4.6 quintillion people. 4.6 quintillion people. Actual, observable, testable, and calculable science tells us the facts. Monkey to man 250,000 years ago, 100,000 years ago, or even 50,000 years ago isn't possible based on human population. It's so impossible that it didn't even happen. So all these computations have been made with the assumption that the human race started from just 2 people. However, evolutionists believe that humans sprang from numerous pairs of ancestors, which would enormously increase these numbers. In these calculations we have made, we have been far more conservative than any self-respecting evolutionist could ask us to be without blushing. So let's take a look at it from another angle. Let's get even more conservative and pretend monkey to man happened 100,000 years ago from a single pair of people. 100,000 years divided by 30.75 equals 3,252. It would take an average of 3,252 years for each doubling to take place to reach the 1922 world population. Taking this rate to the Jewish people, which has been documented and observed, that would mean that instead of there being the over 15 million Jews that we see in 1922, there would only be 5 Jews. From Jacob, which is 3,850 years ago, till 1922, we should only see 5 Jews emerge in that time frame according to evolutionist numbers. And again, they call evolution science. Mathematics disproves evolution. Mathematics disproves evolution. The human population completely blows evolution out of the water. It's impossible that we evolved 200,000 years ago, 100,000 years ago, even 50,000 years ago is impossible. So switching gears here a little bit, let's just zoom in on our galaxy and look at some discoveries that we've made. And so this is a picture of a supernova, which is what happens when a star dies. It explodes and turns into a supernova like this. And astronomers have observed that a star dies every 30 to 50 years and then explodes and turns into something like this supernova. It happens every 30 to 50 years. This is what we've observed. So if the universe is billions of years old, how many supernovas do you think we should see? If we're seeing one every 30 to 50 years and the Earth is billions of years old, we should see millions of supernovas. But do you know what we actually observe? Just over 300. There are just over 300 supernovas that we have observed, and that reveals thousands of years, not billions of years. And so my question is are the stars wrong, or is evolution wrong? So another thing that our textbooks will say is that it takes billions of years for a red giant star to evolve into white dwarf stars. So it takes billions of years for this process to happen. And again, they're saying it in the textbooks as if it's a fact. But remember that true science is about what's observable. And we have not been here long enough to observe something like this taking place. So it's a theory, but it lacks actual observable science to back it up because we can't see it. But we do have astronomers that have been around for a very long time. And so what they see and what humanity has seen in history can absolutely scientifically speak into this because we've been around for a long time observing the stars. So what have we seen? We've seen Sirius for a very long time. It's the brightest star in our sky, and it has turned from a red giant to a white dwarf. This should take billions of years to happen. However, when we look at previous astronomers in history, Egyptian hieroglyphs from 2000 BC describe this star as being red. Cicero in 50 BC stated Sirius as red. Less than 100 years later, Seneca described Sirius as being redder than Mars. Ptolemy listed Sirius as one of the 6 red stars in 150 AD. Today, it is a white star binary. Again, textbooks say this should take billions of years to happen, but this has taken place over just the last few thousand years by observation. We have seen this completely disproven based on other astronomers that have gone before us and observed it being red, and now it's white. It doesn't take billions of years, it takes thousands. So now I'm going to share numerous facts that we've gained again through observational science. And what I'm going to do is I'm actually going to use evolutionists' own theory of uniformitarianism, which is the belief again that the present is the key to the past, meaning that the way we see things happening today is the way that things have always been happening. So let's use evolutionists' own theory, uniformitarianism, to look at the next number of facts. Jupiter is cooling rapidly and constantly losing heat. Its loss of heat is far greater than its ability to gain heat. Since the rate at which it is cooling is measurable and has always been the same, then if it was billions or even millions of years old, it should have completely cooled off by now. Jupiter should be totally frozen over, but it's not, because it's not billions of years old, it's thousands of years old. Jupiter, Saturn, and Neptune all give off more energy and heat than they absorb from the sun, which means all of them would be completely cooled by now if they were billions of years old. Saturn, actually, to focus in on this one, gives off 3 times the heat it takes in. Now, for this issue with them giving off more heat, there are a number of scientific theories out there about why this is so, and that it still proves billions of years, but they remain just theories. I've looked into them, and I don't see them as strong arguments, if I could be honest. And so I believe this is not revealing billions of years, it's revealing thousands of years, because they're just not that old. That's why they haven't completely cooled by now. But another interesting thing about Saturn is that its rings are unstable and expanding away from the planet. The rate at which this is happening makes billions of years in Saturn's age impossible based on what we see today. What about the moon? What about the moon? What has the moon taught us? How did the moon come to be in the first place? What is widely accepted in secular science is the giant impact theory. So this proposes that the moon formed during a collision between the Earth and another small planet about the size of Mars. The debris from this impact collected in an orbit around Earth to form the moon. That moon, the perfect sphere of the moon, was the result of this crash, and afterward began to slowly drift away from where we see it today. And so the moon hit the Earth. This thing hit the Earth, and out of this crazy collision, this beautifully perfect sphere that we see is the aftermath of that chaotic collision. And then the moon began to slowly drift away from the Earth. The observable science behind this theory is that the moon is indeed drifting away from the Earth a little more every day. It's actually just under a few inches every year. And that obviously means that the moon used to be closer to the Earth. Well, in their theory, they believe it came from the Earth. If the Earth is thousands of years old, this isn't a problem. But if it's billions of years old, this creates a problem because the moon affects the tides. And if the moon is closer, then the tides are going to be much higher. If you use the inverse square law and do the math, the effects on the moon being that close to the Earth for that long would have made the planet uninhabitable. The inverse square law says that if the distance is 1/3, the force of attraction between two objects is 9 times greater. The moon being that close to the Earth and slowly drifting away for a very long period of time, that because of how the moon affects the Earth, it would have made the Earth uninhabitable. And we also come to find that the rate at which the moon is moving away from the Earth means, if we rewind it, that the Earth and the moon would have been touching 1.4 billion years ago. Yet secular scientists say that the moon is 4.5 billion years old. This goes against the observable and testable science that we've seen. And so, again, that means that the maximum lifespan on the Earth is also only 1.4 billion years old. So this is a problem for the numbers they projected, because the numbers they have are much greater than this. So the rate at which the Earth is spinning is also slowing down. We have what's called a leap second every year to every year and a half. The Earth is slowing down, and that means that it used to be spinning faster. And so this brings another problem concerning the age of the Earth. If the Earth is a few thousand years old, you wouldn't really notice this slowing down. But if it's a few billion years old, the rate of speed would have been incredible. And so due to what's called the Coriolis effect, the winds would have been 5,000 miles an hour, and the centrifugal force would have been absolutely astounding. Nothing would survive, including plant life. It also means that it would be day, night, day, night, day, night, day, night. If you go back and we see the rate at which it's slowing down, if you go back and it used to be spinning faster and faster and faster, going back even millions of years, that thing is whipping around, man. And so this, again, presents a big problem for the Earth being as old as they say. And, I came up with I didn't come up with this theory, but I thought it was kind of funny, so I threw it in, that this is perhaps what led to the extinction of the dinosaurs millions of years ago. They all got thrown off the Earth as it was spinning so fast. So moving on, let's look at the Earth's magnetic field. And so, as most of you know, the Earth is like a giant magnet with a north and a south pole. The Earth's magnetic field serves to deflect most of the solar wind, whose charged particles would otherwise strip away the ozone layer that protects the Earth from harmful ultraviolet radiation. And when I see stuff like this, it's just amazing to me that this is so designed to protect us. There's like the fact that you would just believe that this came about by chance is a little bit crazy to me. This is obviously a kind designer who's protecting us from the sun. Now, what we've actually observed regarding this magnetic field is that the magnetic strength has declined 10% in the last 150 years and 40% in the last 1,000 years. If you take this rate and go backwards, the Earth cannot be more than 25,000 years old. 25,000 years old. And this is kind of like that timestamp on the coin with the ship sinking from the very beginning of the video that I mentioned, where we have a timestamp here that is very young compared to what we've been told. And that presents a problem, because this field, if it was millions of years old, this magnetic field should be gone by now. The magnetic strength should have been zero a long time ago, and then we'd be in trouble because it wouldn't be protecting us from the harmful ultraviolet radiation. And so this is a really interesting point that just lends credence to the Earth being young. And so what's also interesting about discovering this, is that since the Earth is losing its magnetic strength, this also provides a problem for a radiometric dating that they use, which is carbon-14. Because carbon-14 is produced by the radiation from the sun striking the atmosphere. And if that's been changing, then our radiometric dates have not been constant or consistent, because the conditions haven't been constant and consistent. And yet this is one of the assumptions that's made in radiometric dating, is that the atmosphere has always been the same. And so this has lent to a really amazing discovery, both revealing a younger Earth and also revealing that there's a problem with the way that we radiometric date things. So radiometric dating, let's get into it, guys, because I'm sure a number of you have been thinking as I've been going through some of these videos, well, what about radiometric dating? Like, we know the age of the Earth because of the rocks that have been carbon dated and potassium-argon dated and all these different radiometric decay methods we have to get these ages. We can say with confidence that the Earth is for sure this old. And I think you'll find the rest of this video really interesting when it comes to radiometric dating and the discoveries that have been made around this, and how quiet secular science seems to be around this issue. And so we'll just dive right into it. But this is one of the main methods used for getting the age of the Earth and for telling us it is as old as it is. And so this is taken out of a textbook. It says that once magma or lava solidifies, its radiometric clock begins. By knowing how to do this scientific process, which is just radiometric date things, we can confidently come up with an absolute time. Keep that in mind, guys. Absolute time. Rates of decay are known as the half-life. So once a geologist determines the numbers of half-lives, he or she can multiply by the time it takes for the sample to decay and find the age of the sample. So I'm going to break this down into layman's terms. But the picture here again is claiming that we can find absolute time, and I want to go through how accurate is that statement really. Radiometric dating is based on the fact that radioactive isotopes decay to form isotopes of different elements, and so the starting isotope is called the parent, and the end product is called the daughter. The time it takes for one half of the parent atoms to decay to the daughter atoms is called the half-life. If certain things are known, it is possible to calculate the amount of time since the parent isotope began to decay. And so you can see in this picture here, guys, that the graph there, it's showing you the different number of atoms and the number of half-lives. And in the box beside it, for example, at the top we have potassium-40, which is the radioactive parent. And then we have argon-40, which is the stable daughter. And the half-life is 1.25 billion years. And so if you keep going, you can see uranium to lead is 704 million years. That's its half-life. And carbon-14 to nitrogen-14 is 5,730 years. So that's its half-life. So I just want to take a second to elaborate on these half-lives that they're talking about, the half-life of these elements that are changing into other elements, and so that we just all understand moving forward. But take this turkey, for example. You know, throughout this turkey's life, it's going to be accumulating carbon-14. And then when it dies, it's no longer taking in carbon-14, and so the clock begins to tick in which that carbon-14 is decaying into nitrogen. And the amount of time it takes for half of that life in carbon-14 to decay has been calculated to be 5,730 years. So after 5,730 years, half that amount of carbon-14 that was in the animal is gone. And then you add another 5,730 years, which gets you to 11,460, and half of what was remaining before that half is also now sliced in half and is gone. So just to put it simply, if you had 1 gram of carbon-14, after 5,730 years, you would have 0.5 grams. And then you add that half again to that and get to 11,460, and you'd have 0.25 grams of carbon-14 left. And so that's just a simple breakdown of the half-lives that they're talking about. And so all these different radiometric dating methods have various different half-lives, and carbon-14 is one that has the youngest, and then something like potassium-argon can have, I think it's 1.4 billion years is its half-life, and so that's how they get these different calculations. So I just want to just show you another quick example of how this works and what it looks like, just real simply, because using it in rocks, this is how we have so often come up with the age of geographical locations and the ages of rocks and different volcanic eruptions and all kinds of things. And so just real simply here, you can see that this uranium starts out as a full block of uranium, and then it's half uranium, half lead, and then eventually it turns into being completely lead. And so this is something, again, we use to get the ages of different rocks by knowing the rate at which this decay happens. And you see it from uranium to lead or potassium to argon. There's a number of different radiometric decay methods that we use, but they're all using the same method, if you will. And so theoretically, for this one, it would take billions of years for a solid piece of uranium to turn to a solid piece of lead based on the rates of decay that we have today. And so the idea is that if you find a rock with some uranium and then some with lead, and since we know the rate at which that decay happens, we can use this information like a clock to tell us how old the rock is. And that will also help us determine the age of the Earth, because the Earth is obviously going to be older than the rock. Now, the problem with this is that there are three major assumptions that are made when we approach radiometric dating. And I'm going to get into those in the next slide. But a question I want to ask is, when you find a rock that's half uranium and half lead, how do you know that that rock that you found, being half uranium and half lead, was really solid uranium to begin with? You can't know if it already had some lead in it from the very start. So this would greatly inflate your age limit. Now, in all honesty, secular scientists know that the rock had some lead in it to begin with, but how much lead did it have? And this is where it gets a little bit tricky, because, well, you tell me how old you want the rock to be, and I'll tell you how much lead was in it. We can't know. And so there's assumptions that are being made that greatly affect the ages in which we get. And I'm going to get into those assumptions in the next slide. So I want to give you guys just a simple illustration to help explain these assumptions that are made when it comes to all radiometric dating methods. And we're going to use this hourglass so you can kind of have a visual of what I'm talking about. But the first assumption is that the rate of radioactive decay is known and has been constant since the rock formed. And so in other words, if you look at this hourglass, you see that there's a bottleneck there, and the sand is slowly going from one chamber to the other. And so the top chamber represents the first element. In our last example, I had uranium turning to lead. So let's pretend in the top here, the top chamber represents uranium, and the bottom layer represents lead. And so this uranium is slowly decaying and turning into lead. And so the issue is, how do you know that the bottleneck, the rate at which that sand is going down, or uranium is turning to lead, has always been the same? You have to assume that it's been constant. And yet we can't be confident that it has always been the same throughout Earth's history. And in fact, there's actually very compelling evidence that it has not always been the same. In a laboratory, for example, some decay methods tested can actually be sped up by a factor of 1 billion. And so we don't know whether the bottleneck of this hourglass has always been that exact same size. In history, it could have been a lot bigger and then got smaller, or it could have been even smaller and got bigger. We don't know, and you have to assume that it's been constant. And yet, again, there's evidence that goes against that being so. And so this is the first assumption you have to make. The second one is that there has been no loss or gain of a parent or daughter isotope from the rock. And so looking at the hourglass, we don't know if at some point sand was added to the top or added to the bottom, or if sand was removed from the top or sand was removed from the bottom. We don't know if there's been a loss of uranium or a gaining of uranium, or a loss of lead or a gaining of lead. And in fact, we have observed, and you can prove this scientifically now because we've seen it, is that uranium is actually leachable in salt water. And it can move in and out of the rock in salt water. And this would totally mess with the actual age based on the method that's used to age it. And so we observe that sand is absolutely added and removed based on observations like uranium and salt water. There was a parent isotope that was moving in and out of the rock. That would totally mess with the age because of the assumption you're bringing to the table when you have to do radiometric dating. The last one is number 3, that the amounts of parent and daughter isotopes present when the rock formed are known. And so, just as an example, looking at this hourglass, I would say to you, if you walked into a room, let's say that this hourglass represents just that 1 hour, and you were to walk into a room and you would see this picture as it is right now, and I would say to you, how long ago would you say that I flipped this hourglass over? And you'd see a little bit of sand at the bottom, and most of it's at the top. And based on an hour, you'd probably say, well, maybe it's maybe about 10 minutes have gone by. And I would say, no, I actually flipped it over 10 seconds ago. There was already sand at the bottom before I flipped it. And this is the third mistake that's made in radiometric dating, which is called the assumption of initial condition. And it's the third assumption that must be made when you go and use radiometric dating. And so I'm just going to show you as we move on that this has been a real problem when it comes to getting real ages of things that we've tested. And you'll see this in a minute, because we've tested things where we've absolutely known its age and then got wildly wrong results when we went to find out if these radiometric decay methods actually work. So we'll get into that. So I want to show you guys two different radiometric dating methods that we've used to come up with different ages of things. And so the first one is going to be, we're going to go through carbon-14. And I'm going to use that one because it's one of the youngest ones. It gives us it can only last up to 50,000 years. And so it's relatively young when you consider that they're telling us that the Earth is billions of years old. And you know, I've heard some scientists say that it could last up to 90,000 years, but it's most commonly accepted that it only lasts 50,000 years. And so we're going to use that one first because it's a younger one. So we're going to take a deeper look into that. And then the next one we're going to use is potassium-argon dating, because it has a half-life of 1.4 billion years. And so it's given us a lot of older ages for geographical locations and different kind of rocks and volcanic eruptions that have taken place. And so we're really going to look at a young one and an old one and really see, is it actually as absolute as we've been told it is? Is radiometric dating really absolute? And so we're going to look at some surprising finds and discoveries that we've made in actually testing this radiometric dating method out. And again, it's just not something you hear in secular science. And I think it's only right that we have all the information so we can come to our own conclusions. And so this is just a picture of how carbon-14 dating really works. I've gone over it, you know, kind of a little bit already, but here's just to solidify it. So carbon-14 is produced in the atmosphere, and again, it's when the sun strikes the atmosphere, there's carbon-14 that's produced, and it oxidizes and forms carbon dioxide, which gets absorbed then into the plants, and then the animals eat the plants, and it's incorporated into the animal bones and other tissues through the metabolic process. And then when the animal dies, their metabolism ceases and their tissues stop incorporating C14. So the C14 begins decaying into nitrogen. And the rate at which it does this is again seen through the half-lives that I've already gone over. And so again, carbon-14 dating is assuming that the atmosphere that we have today is the same atmosphere that we have always had. That's one of the assumptions I went through. However, as we've already seen, the Earth's magnetic field is getting weaker and weaker, and this means that our atmosphere is changing, and this would totally mess with carbon-14 dating. And so that's just an important piece to point out. So I want to go and show you guys now some actual evidence. When we have tested this thing out, how has it actually gone? And does radiometric dating work? And so I'm going to go through a number of things with you to show that. And so this one was a pretty interesting find. They found insects in amber, which is petrified tree sap or resin, and along with these insects that were trapped in this tree sap was air bubbles. They had little air sacs in them, and so they measured the air to see if the air used to be different, because these were thought to be quite old. And they found that there was 35% oxygen in the air bubbles compared to the 21% oxygen that we have in our air today. And so this, again, guys, just goes to show that our atmosphere used to be different. And because they use the belief system that it has always been the same and constant, then that is something that totally messes with the accuracy of carbon dating. And so that's what I want to show you guys now, is just how all over the map carbon dating really is. For example, the lower leg of a mammoth had a radiocarbon age of 15,380 years, while its skin and flesh were rated to be 21,300 years. That's a big difference. When you're looking at something that can only last 50,000 years, that's already seeing quite the error take place from a leg to the skin of the exact same animal. Another case was one part of a mammoth carbon dated 29,500 years old, and another part of it dated 44,000 years old. Guys, that's a 14,500 year difference. Does that sound scientifically accurate to you? That is a big difference in the age of the same animal. Another part of a baby frozen mammoth was dated to be 40,000 years old, and another part was 26,000 years old. The wood immediately around the carcass was 9 to 10,000 years old. That is a 30,000 year difference. And again, this is something that can only last 50,000 years. So look at the amount of error that is in something that should be incredibly accurate based on what secular scientists tell us today. That's a really big difference. So here's another interesting example where some Russian scientists discovered dinosaur bones had a carbon date of 30,000 years. And 4 other dinosaur bones, samples were carbon dated to be 20,000 years old. Isn't that crazy? And what's also kind of, I find suspicious, if you will, about this is that the samples were not identified as dinosaur bones in advance. And what happens a lot of times when it comes to carbon dating these things is that carbon dating is actually, it's not all bad. I think it's actually our friend in the sense that it's revealing how young things really are. Because carbon-14, it should be absolutely impossible for it to exist in dinosaurs, because we've been told that dinosaurs lived between 245 to 66 million years ago. So what's carbon-14 doing in dinosaur bones if they're really that old? And so in that sense, carbon-14 has actually been our friend, because again, it's revealing that the Earth is nowhere near as old as we've been told it is. And so, for the longest time, dinosaur bones weren't even tested for carbon-14 because it was assumed to be absolutely impossible, since they do believe that the dinosaurs lived so long. So the presence of carbon-14 in these bones again just makes it impossible that these bones are actually that old. And so this was an interesting find where carbon-14 was actually working for us, in the sense that it's revealing apparently ancient things are not as ancient as we've been told. Now, carbon-14 dating continues to get even more interesting. What if I told you I found an immortal snail? And if you ate it, you would live forever. I'm kidding. But shells from living snails were carbon dated as being 27,000 years old. These snails that are alive right now are apparently 27,000 years old based on carbon dating. And I think we just found this immortal snail that's going to help us live forever. So they should definitely be doing a lot more research on that little guy. In another experiment, a freshly killed seal was carbon dated as having died 1,300 years ago. 1,300 years ago. They just killed it, and they were testing to see how accurate this carbon-14 dating is. And as we continue to see, guys, it is not trustworthy at all. So here's another one, guys, where there's researchers here that are looking northward and down into the floor of the Mount St. Helens crater, where the volcano has erected a 100-foot tall lava dome. So radioisotope ages of 10-year-old rocks, they knew they were 10 years old, from the dome were dramatically incorrect. And, it's amazing, because they have these rocks where they know for a fact how old they are. And then they do these radiometric dating methods on them, and they get wildly wrong numbers. And when I get into potassium-argon dating, I'm going to come back to Mount St. Helens, and I'll show you just how wildly wrong they really were. And also, something really interesting was stated when it comes to this dating methods in 1970 at the Nobel Symposium in New York. And this is what some scientists said. They said, if a carbon-14 date supports our theories, we put it into the main text. If it does not entirely contradict them, we put it into the footnote. And if it is completely out of date, we just drop it. And so what he's saying is crazy here, guys. He's saying, in other words, we put the dates on things that we want, and we scrap others that don't line up with what we believe. And again, guys, this is not science. You are throwing out good, testable, readable evidence because it doesn't line up with your worldview. You're not throwing out the evidence because it's bad. You're throwing it out because you don't like what it's telling you. And that's not science, right? And so they just said it straight up here. And I think it's important that we know that, because, again, in most secular science, you just don't hear this stuff, which is why I'm wanting to share it with you. So just in conclusion here to carbon-14, I've shown you just a few examples, guys. I didn't want this video to be like 5 hours long, but there are so many more examples where testable, repeatable, observational science has taught us carbon-14 dating is absolutely unreliable. And so these are some things to consider, that if the samples of known ages, where we knew what the age of something was, and then we did carbon-14 dating on it, and it gave us a wildly wrong number. And so if it's doing that with things where we know the age, why would we be trusting it to do it for the ages of something that we don't know? It just doesn't make any sense. And so radiometric dating, specifically carbon-14, I'm going to go into potassium-argon dating with you, but carbon-14 dating is unreliable and unpredictable, and it does not work to get the age of something. So let's move into now potassium-argon dating. And so this is something they use to get the age of things that are supposedly much older. I think before I said the half-life was 1.4 billion years old, but I was wrong. I meant to say it's 1.25 billion years, so a couple million years off there. But anyway, very old. 1.25 billion years is the half-life for potassium-argon. And so you can see in this picture here that crystals grow in the magma chamber, and then potassium goes into the crystals. And then the volcano erupts, and magma and crystals form tephra, or ash. And over time, the potassium in the crystals radioactively decays into argon. So just like uranium goes to lead and carbon goes to nitrogen, this is one where potassium turns into argon. And they believe they know the rate at which this happens, and so they can use it to test the age of places where volcanoes have gone off in the past, and there's been eruptions, or they can also use them to geographically date areas. And I'm going to show you some examples of that later on. But again, potassium-argon dating is a method that they've used to show us just how old they believe the Earth really is. But again, just like carbon-14, let's see how accurate this dating method really is. So my first example is Sunset Crater in Arizona. And you're going to see, guys, that the three assumptions that I mentioned earlier in radiometric dating are applied to all of them. So this is included in potassium-argon dating. Those three assumptions are being made here as well, and we're going to see just how wildly off and wrong potassium-argon dating has been with what we've observed and tested. And so again, this is Sunset Crater. This is a volcano in Arizona, and we know for an absolute fact that about 900 years ago, this volcano erupted and buried a First Nation tribe that lived at its base. And so a number of native artifacts were trapped in the material from its eruption. And they used potassium-argon dating to date the lava rock from the eruption, and came up with numbers that were wildly wrong. So the potassium-argon dates that they got were showing that this volcano erupted between 230 to 250,000 years ago. And yet we know that this erupted 900 years ago. That's a few 100,000 years off. And so this is one where we've seen in Arizona that potassium-argon dating is very unreliable. So here's something called the KBS Tuff, which was named after a certain scientist who went and saw this layer of volcanic material that they wanted to date and kind of research. And so they did potassium-argon dating on it, and the layers of this tuff came out as being between 212 and 230 million years old. This was done in 1970. And that was until and then they did this right up in 1985. But then there was a man named Richard Leakey that came to the same site in 1972. And he decided he wanted to dig underneath the tuff and see if he could find anything there. And he did find something very interesting. Keep in mind, guys, that this is 230 million year old tuff according to potassium-argon dating. And underneath it, he found a human skull. So this was a big problem because they believed at this point in writing, and when they did these digs and these finds, they didn't believe that humans evolved 300,000 years ago. They believed at this time that humans evolved 3 million years ago. This is just these numbers. The numbers keep changing like crazy. It's hard to keep up with this theory, to be honest. But at this point, they believe that humans evolved 3 million years ago. So this is a big problem because they now have a human skull that is underneath a layer of rock that's over 200 million years old. And if it's underneath that, that means that the skull is older than 200 million years old because it's buried underneath it. And the skull was actually dated at being 2.9 million years old. And so this was a real problem that kind of sent the scientists scrambling for answers. So first they thought that maybe someone dug through the rock and buried it there. Or maybe there was an earthquake that opened the ground and the person fell in. And after exhausting these theories and finding them to be impossible, there were two groups of different scientists that came up with two very different answers. And based on the two different answers they gave up, I think only one group was actual scientists. And that's just because one of the groups said that they believed this was evidence that aliens were actually here 200 million years ago. And so I'll let that one be alone. But the second group decided to take more samples of the rock, even though they had already been dated numerous times and they had come up with a few 100 million years. And this was something that they emphatically agreed on. And so the only reason they're retesting these rocks is because they have found evidence underneath that goes against the theory of evolution and what they believe. And so like, well, man, if these rocks are 200 million years old, then the skull that's underneath it is obviously older than that, but that's impossible because humans evolved 3 million years ago. And so they wanted to retest this and see what they could come up with for numbers. So we got to do this again. So after all of this retesting, all of a sudden these new ages came out that gave the rock layer between 520,000 years and 2.64 million years, which I also find is neatly under the 3 million that they believed that the humans evolved from, the 3 million years. And so this completely changed. And again, guys, does this sound like science to you? Adding more to the problem is that they now believe we didn't evolve 3 million years ago, but that rather we evolved 300,000 years ago, making this find all the more problematic. What is a human skull doing dated 2.9 million years old under these rock layers that even if they were 520,000 years old, you still have a human skull underneath them. This problem actually intensifies with what they now say about the time frame of human evolution. And so just in conclusion, guys, to go from 212 to 230 million years old to 520,000 years old is a 44,000% error. That's intense. 44,000% error in this potassium-argon dating. And they would have never redated these rocks had the skull not been found underneath it. And like today, everyone would have believed these false numbers, these original numbers they gave. And this begs the question, how many other dates out there are totally wrong, right? Because if that skull was never there, they would have just said, yep, this layer is 212 million years old, and they would have walked away, and everybody would believe them. The only reason they redated was because of that skull. And then the numbers got wildly different to match their theory of evolution at that time, which today blows it out of the water because it's just so the numbers don't line up at all. And so again, guys, we just see a big problem with potassium-argon dating. So next this is a piece of lava rock found at a mine in Australia. Sorry, the picture isn't that great. It's kind of fuzzy and grainy. But you can look this up for yourself and see this stuff as well. And so it's from a mine in Australia where an eruption took place, and it encased a piece of wood, which burned it into a charcoal. With the wood sealed in the lava rock, it would be totally uncontaminated. So this is kept safe in there. So the age we get from this should be pretty accurate. With this rock, both radiometric dating techniques can be used to supposedly find when the eruption took place. So for the charcoal inside, you use the carbon-14 method, and for the lava rock, you use the potassium-argon method. So using the carbon-14 dating method, the results said that the charcoal was 45,000 years old. But using the potassium-argon method, the results said that the lava rock that was encasing the charcoal was 37 million years old. That's a 36,955,000 year difference for something that's the exact same age. Isn't that crazy? And so they took 4 more samples from the top left: lava rock with charcoal intact, fossil wood, and then basalt with holes from former gas bubbles, and a fossil tree with roots and siltstone. And in fact, the 4 samples taken, the results were the same within the 4 samples. For the carbon-14 dating, that gave you the age of 44 to 45,000 years old. And the rocks, potassium-argon dated, gave an age of 37 to 45 million years old for something that's exactly the same age. Does that sound like it's accurate to you guys? Right? So it is just something that we continue to see. So let's look at just a couple more and then I'm going to end the video. But it is known and recorded in history that Mount Etna in Sicily erupted in 122 BC. Basalt from the eruption was tested and potassium-argon dating method gave it a date of 250,000 years old. And yet it happened in 122 BC. We know it happened in 122 BC. And that's a 248,000 year difference. We know for a fact it was 248,000 years off. Not an accurate method of dating. So here's another example of dating in Hawaii. In Hawaii, potassium-argon dated something that was 1.4 to 2.2 million years old. The real date was 1801, like just over 200 years ago. It erupted in 1801. And some rocks from Hawaii that were known to have formed only 200 years ago gave a potassium-argon date of this 1.4 to 2.2 million years. And yet we knew the age. That was wildly, wildly wrong. And, here's one more in Hawaii. Another eruption happened in 1955. 1955. Here's a picture of it happening. We have a literal picture of it happening. But when it was potassium-argon dated, it gave a date of 8.5 million years. Yes, 8.5 million years this volcano erupted, and yet we saw it erupt with our own eyes in 1959. That is wildly wrong. And here's the last one. The famous eruption of Mount St. Helens that happened in 1980 had 5 different rock samples dated radiometrically and ranged from the youngest being 350,000 years old to 2.8 million years old. And these rocks were dated when they were 10 years old. They knew the age of the rock. They were formed from this volcano and they were 10 years old. And yet the youngest rock, radiometric dating said it was 350,000 years old, and the oldest said it was 2.8 million years old. It erupted in 1980. We saw it with our own eyes. So again, guys, observable science is showing us again and again that radiometric dating is not reliable. And so potassium-argon has the same issues as carbon-14 when it comes to its accuracy. It is all over the map and it has been proven to be absolutely unreliable. So again, the same thing with potassium-argon dating. It doesn't work for ages that we know, and so why are we assuming that it's working accurately for ages that we don't know? Radiometric dating does not work. And you guys won't hear about this in secular science. They don't like people knowing this because, again, it's just one of the main ways that they have come up with this supposedly very old Earth. And, the other thing is, too, we find carbon-14, which, again, can't last longer than 50 years. We find that in coal. We find it in diamonds, and we find it in these coal seams that are supposed to be hundreds of millions of years old, and diamonds that are supposed to be ancient. And yet there's carbon-14 in them. That's absolutely impossible if they're as old as they're saying they are. And so, it's a really interesting topic. I hope you guys enjoyed the video. And I'm going to get into some more things that, again, have shown us an appearance of age when there actually isn't age. Things don't take as long as we've been told. So we're going to get into a bit more of that. And, we'll see you in the next video.